transformer, like we explained earlier, is the same thing too. Okay, the primary here, primary here equal resistance. Secondary here and here equal resistances. So our measurements, they are supposed to be the same. Okay, so if you measure between here and here, because once this one is connected, immersed in your oil, okay, you can only access the terminals outside the transformer. Okay? So if this is the high voltage side or low voltage side, as the case may be, so when you test between here and here, you're actually testing the resistance of this winding. Between here and here, you are testing the resistance of this winding. Between here and here, you are testing the resistance of this winding. Since this is the start point, this is your neutral, line 1, line 2, and line 3. So expectedly, the resistances are supposed to be the same. Okay. So if you are looking at the high voltage side, you only have these 3 connections. This start point will not be connected out. If it is start connected, if it is delta connected, the same thing too. Okay, you only have 3 connections. So these are the various connections, okay, on the primary side. So like we explained, this too also is true for the electric motors case. So between line 1 and line 2, you are measuring this. So the argument is that this one is in parallel with this one. Are you getting that? Is A is in parallel with if you put your test probe here and here, A is in parallel with B and C. The same thing too, if you put here and here, C is in parallel with A and B. Okay, when you put here and here, B will be in parallel with A and C. So expectedly, however you look at it, your resistance reading must be the same. It's only when you have some issues that they will be different. So this is the star connection as we explained here earlier. So generators 2 is the same. We can only access these terminals at the terminal block. We cannot access this. We cannot access the feed winding except with the couple as we explained earlier. So the test too is the same with that of electric motor. So you can take the neutral point, which is the start point, test to here. That will give us the resistance of this winding. Test to here will give us the resistance of this winding. Test to here will give us the resistance of this winding. Expectedly, they are supposed to be equal. Okay. So if you can access the terminal block like this, we can disconnect the start point, which is this point, and then test the resistances of each of the windings. Okay, that will give us there is basically no need for that because the neutral point is out here already, this neutral point. Okay, so from here to here will give us the A winding resistance, from here to here will give us the B winding resistance, here to here will give us the C winding resistance. So we use any low resistance meter, micro ohm meter, to carry out the winding resistance test. So the results that you get from your winding resistance we have been explaining before. Okay, that the results, they are supposed to be almost equal. Then you look at the percentage difference. Okay, expectedly you don't expect to have any difference if everything is done or was done perfectly. That is during the rewinding or during the manufacturing of that particular asset or equipment. So this is what we have between U and V. These are the various resistances. Okay, so this is the deviations or the percentage difference. See that it's very low. So this is on the high voltage side. So all of these, they are acceptable. As you see that they are low. Okay, then if you look at these two, you see the percentage difference is also low, a little bit high, but it's low. So if it is electric motors too, that is what you should be expecting too. Are we getting it? They should be about the same values. Okay, it's the same thing. like we said in the course of the training earlier, training the result is only then that it will make meaning to you, so that when degradations are setting in, you'll be able to know and see when the degradations are setting in the exact time, and see how to do take the necessary step to carry out to restore the equipment back to its functional status. So now, as look at this trend, okay, we are talking of the installation now. When each time you go to your facility, okay, during operation, you take the equipment out of service, during your normal PM or so, you carry out your tests, then you record your test, you plot against time. So they should be fairly equal on the same, are you getting it, on the same level on each test. So you see that, remember our bar top curve in our initial earlier section, okay? So you see that as the deterioration is setting in, the value is dropping over time, okay, which is normal due to age or aging of the equipment. You see this deterioration, you see when the aging effect is setting in, okay? So you can only get to notice this when you do training, that is, you record and then you plot, okay, the value against time. So you see, when you have a plot like this, you see that you are already entering the PF region, okay? That is the parameter that you are monitoring. In this case, the insulation resistance is dropping at a rapid rate. It's dropping very fast, okay? So when you enter this PF region, that is the importance of trending. You will know and then take the appropriate corrective measures to bring the insulation back to operational status. You see, after the equipment is fixed, okay, you can fix it and gain, depends on what is actually causing it. You can fix it and gain your normal insulation level and follow the normal curve, okay? Or it may not be possible to restore it back to what is normal, but it will be improved to an acceptable level, and that will extend the life of that particular equipment instead of it failing here, okay? So you see that your intervention has actually improved and extended the life of the equipment. So that is the importance of testing, recording your test results, trending your test results to ascertain when there are deviations or when things are becoming abnormal, or to ascertain when you are entering the PF region, okay, of that particular parameter that you are measuring on the equipment. So this is another important example of trending, though this is one of the PI tests that we discussed during the time test for insulation resistance test, okay? So you see, for the good value, the trend expectedly is increasing, okay? Then for the poor value, maybe the insulation have moisture trapped in it or dirt, something that is compromising the insulation. So you see that upward trend is not there any longer, okay? So for the step voltage test, the same thing for poor insulation. So all of this actually highlights the importance of trending. This is a test on an electric motor, the result of a test on an electric motor, the leakage current. Remember, the lower the leakage current, the better for us. So you see each of the curve for different times when the measurement was done, okay? So remember, the leakage current gives us an idea as to the dielectric strength of the insulation, okay, or in our equipment. So you see that the leakage current over time is increasing, probably because of age. You see here, it's actually 1st of January, it actually overshot. Are you getting it? So that will give us, so you see the trend, okay, until it overshot. Okay, so when it is restored, this measurement was done and we saw this. And look at the date. So that is the beauty of trending. And for you to get the value of your measurement and testing, you need to trend. Okay, because remember, each equipment, they are subjected to different operational conditions. Even if both of them are produced to withstand the same amount of pressure during operations, in the actual operations they are subjected to different conditions, so you don't expect the same result from them. Okay, so when you make your measurement, you test on a particular and then you trend, you come to know the behavior of that particular equipment as regard those parameters that you are looking at in each of those your tests. Okay, so this is similar to what we described earlier to highlight the importance of trending your test results. Okay, so the beauty of this again is also that if there are no industry standard with you, you already know the characteristics of that equipment from your previous tests and measurements. Okay, so when there are deviations, when the equipment was working normally, you know their response to those tests. So when there are deviations, you also know, and those deviations, they are indications that something ugly is happening within